If you have used FastAPI in the past, I don't have to convince you that it's a great piece of technology written for Python developers to make APIs at a warp speed. Using FastAPI, we can create APIs of any kind such as get, post, put, delete within only few lines of code. If you have not used FastAPI, I highly recommend you guys to check out FastAPI. In this video, I am assuming that you already know FastAPI. You have already worked on some kind of project where you connected FastAPI with database using SQLAlchemy or maybe a migration system like Alembic. The focus of this video is going to be how to deal with spatial data. That means connect your PostGIS table which has some kind of geometry related column and then create APIs using that. Migrations are also important in FastAPI because they allow us to see all the changes that have been made to the database in an organizational manner. In this video, we will set up our FastAPI application, then we will set up our migrations, and finally we will create APIs. If you are interested into copying the code that I am going to write, you can find the blog link in the description down below and you can simply copy the code from there. Alright, let's go ahead on the computer screen and see the code in action. Hi there. So this is the blog that we are going to refer throughout this video. The reason of this is I want to copy a lot of code from here so that I can save my time during the video. If you are interested into the entire code, you can simply go to this GitHub repository, give this a star and clone this repository. But for this video, I am going to do everything from scratch. So as we discussed earlier, we are hoping that you already have worked with PostGIS in the past. You know a little bit about GeoAlchemy, you have worked with FastAPI, and you might have also worked with SQLAlchemy to handle database session and queries. In this video, we are going to create everything from scratch. So let me head over to my terminal and create new folder on my desktop. So I'll give it a name Spatial FastAPI, and then I will create my environment variable. So I'll give it a name as env. I'll activate my environment variable, and the first thing that I will do is install FastAPI. I'll also upgrade my pip, and at this point we will open this in our VS Code. So I'll do code dot and there we go. Now we want to keep our folder structure like this. So we have environment variable and we will create app and then main.py in that folder. So I'll do app/main.py. This will create the folder as well as file in it. Okay, and here we will write our boilerplate FastAPI code. Now if you are using some kind of plugin like Amazon Q or GitHub Copilot, you can simply give the comment saying that FastAPI boilerplate code. But if you don't have anything installed, you can simply go over here and copy this code from here. In my case, as you can see, I got my boilerplate code, and since we are living in 2025, we should definitely use AI and LLMs wherever possible. Okay, now that we have our boilerplate code, we will go into our app folder and run our code by simply calling uvcon main app reload. And then this will start our FastAPI code, and you have your first API. And not just that, you can also go to /docs, and this will open your OpenAPI documentation of your entire application. See how much easy it is to set up the API. Now it's time for us to add database settings to our FastAPI application, and to do that we will first of all do some installations. So I'll install SQLAlchemy, which can help us to manage my database session and write ORM queries, GeoAlchemy specifically to deal with location data, Pydantic settings for writing the settings of our environment variables, asyncpg to create async functions to deal with Postgres, and Greenlet. So I will simply copy this and paste it over here. I will stop my server and paste it over here. Okay. Now we will first of all create our environment variable. Before we create that, we have to be sure that we have a database with which we will work. So in my case, I will create a new database known as fast video, and I will also make sure that the PostGIS extension is installed in this. So to do that, I will do create extension PostGIS. Alright, so my database name is fast video. Now I will create an environment file and I will put my database URL in that. So again, we will go to our app folder, create a new file known as env, and we will paste it over here. We are going to use PostgreSQL plus asyncpg as our driver. Then the username is Postgres. In my case, the password is also Postgres. I am using localhost database at port 5432, and the name of my database is fast video. There you go. So this is the correct path to define your database variable. If you don't want to use environment variable, that's totally fine, but it's a good thing to do it so that all of your secure credentials are within your computer and they never leave your actual computer to something like GitHub. To do that, we will also have to be sure that we have a gitignore file with .env written in it. Now we will create a config.py file in which we will actually get the settings. These settings are nothing but all the things that we have written in an environment variable file, and that's exactly where we need Pydantic settings. Earlier, base settings was part of Pydantic's main class, but now they have created another package known as Pydantic settings, from where you can import the base settings. Since we are only dealing with database URL, we will give that as a string, but in your case, if you decide to make that as a separate thing, like maybe db user, db password, like that, then you will also have to mention all of those things over here. We are going to deal with environment variable file with the name .env. So again, this can be something like .prod.env or anything like that. And finally, we initiate a settings variable which will have all of these data with it. Next thing we do is we initiate database.py file. So I will go with database.py, and there you go. So the first thing that we are doing is we are importing these settings from our config.py file. The reason that we want to get access to the database URL that is there in the environment variable file. Then we are creating a sync engine using this database URL, which can be used to create session with our database. So here we are defining engine with create async engine, giving the database URL, future is equal to true and echo is equal to true. By keeping echo is equal to true, we can see what is going on in our terminal whenever we make any kind of database request. Then we initiate a session by giving this engine and defining this as an async session. We are not expiring it on commit. We then declare the base class and then we create a function known as getDB. That means whenever someone goes to the home page of our application, we will want to set up the session so that whatever requests are being made can be made using that session. Finally, we will also create our models. So to do that, I will create models.py and I will paste this over here. So in this case, we are creating a simple database model known as item, which will have ID, name, description and geometry as a point. You can see over here, we are pulling geometry data type from GeoAlchemy. Here you can replace this with something like line string or polygon, totally up to you. For the sake of this video, I will keep it as a point. Feel free to create more tables as you go forward. Here we are keeping ID as a primary key and we are indexing the ID as well as indexing the name. And then we will also create schemas. Schemas makes our life very easy because as the application grows, we keep on making changes to the database columns, and if we don't make those changes in the schemas, our application will break, which makes it very easy for us to understand that why it is not working the way it should be. For example, if someone passes integer to the name column, we want to catch that and we want to give that as an error saying that you should pass string and not integer. This is something that can be done using schemas. So we create a base schema of item where we send ID and all the things in item base like name, description and geometry. This item base can be used to create new schema because obviously ID will be generated on the fly, but as a post request user will only send name, description and geometry. And that's why we have created one more class known as item create, which is extended from this item base class. Alright, now our setup of our database and models is done. We will quickly go to our terminal and try to run our UVCon code just to be sure that there are no breaks that are there. So now you can see that I can still go to my home page, I can still go to my docs page and I can have a look at it, run this and get hello world as a result. Now that our database settings are done, it's time for us to migrate this to the database. Now of course one of the ways is that we can go to the schema, public, tables and maybe create a new table with the name item and put all those things. But we don't want to do that because if we do that, it will be very hard for us to understand whenever someone makes the changes to the database, what all things we have to also change in our application, and that is why migration tools such as Alembic are so famous. But having said that, it's a little bit tricky to set up Alembic working with the geometry data, and that is exactly what the purpose of this video is. So the first thing that we do is install Alembic. So I'll stop my server and install Alembic. Once done, we will initiate the migration. By initiating migration, few files and folders will be created in our application. Now let's have a look at what all changes are there in our code structure now. First thing you might notice is that now we have this alembic.ini file. And then we have a totally different folder known as migrations. This again contains some folders and some files in it. We are going to have a look at each one of these settings because if you screw up any of these settings, your migrations will not work. And believe me, it's very frustrating when your migrations doesn't work. So the first thing that we will do is edit our alembic.ini file and put our database URL over there. So I'll just simply look for SQLAlchemy URL and I will replace the default string with our database string. Now the next thing that we want to do is to make changes to the env.py file. Now this is going to be the tricky one, so I want you to pay attention. The existing env.py file has some imports, then initiation of the config and then functions to run when we do migrations in online and offline mode. This is extremely important because in order for Alembic to work with SQLAlchemy, we have to make certain changes to it. Now before we get into that, I would like to explain to you how Alembic will work. Alembic will keep an eye on the models folder, and whenever a new table is added or maybe existing table is deleted, it will try to understand what all columns are there and what are subsequent column types are there, and then it will create that particular SQL query which will either add those columns to that table or remove those columns from the table. So this is extremely important for two reasons. One is that you might have noticed that when we install Postgres, we get this table Spatial ref sys, which essentially refers to the all special referencing system that are there in Postgres. And we definitely don't want to mess up with this table. That means this table should not be part of your migrations. Your migrations can change any table except this one. And that is a setting that we need to put over here. Another setting that we want to take care of is the creation of indexing. In our case, indices are created for ID and name, but we don't want to do that for geometry using Alembic. That means we have to stop Alembic from doing two things. One is making index for geometry and one is from making changes in the spatial ref sys, and both of these things will be done in this env.py file. Now let's head over to the blog and copy things one by one. So I will copy this and then I will explain it to you. So few things that we have added is, first of all, we have added this async engine from config because we want to make certain async requests. Then we have also imported this base because we want the target metadata from our own base. Then we are checking the type of our column by checking this check special type, and then we are referring to the certain geometry types like geometry, geography and raster. In this video we are only going to deal with geometry, but even if you want to deal with geography, you can do that. Next thing that we want to do is we want to make changes to the metadata. So for example, instead of having none, we will say that okay, take the base metadata information from our model. Then we want to create two new functions. One is render item and one is included objects. Both of these are default functions from Alembic. That means you can read more about these functions on Alembic's official documentation. Let me explain to you quickly that what does this mean. Include object is one of the parameters that will go in this configuration. So I can simply write include object over here, and same for my online migration as well, but we will not have a look at it right away. First I would want to tell you more about include object. Now this include object will run whenever we are migrating, and what all things we want to check. First thing is that we want to check that if the type of migration is index, and if the column type is either geometry, geography or raster, we don't want to make any kind of changes in that, and that's why we are returning it as a false. And the second thing that we want to check is if the type is table and the name is spatial ref sys, again we don't want to do anything with it, and that's why we are returning false for both of these conditions, and everything other than this is true. Now what does this tells you? Let's say you have certain table, it doesn't have to be spatial ref system, it can be anything. Let's say if you have any kind of table and you don't want that to be a part of your migration, you can simply copy this and paste it one more time and make the change with the name over here. Maybe it can be something like user payment. You don't want to mess up that table, so you'll simply say that do the migration the way you want, just don't touch this particular table. In our case, spatial ref sys is that table. Alright, now some of the changes that we have to make. First thing is that we have to get SQLAlchemy URL from our config. I think that's already there. Then the next thing that we want to do is include object. Now in offline it is fine, but our main focus is on online. Now to do that, we are going to split this run migration into two functions. First function is the actual migration that will happen. That means I have given render item and include object over here, and second is to convert this into a async function, because as you have noticed, we have created everything related to database in an async mode. That's why I will simply copy this function and paste it. I will also change what is happening over here, because here we would want to run this in an async manner. So that's why I am simply importing async IO and running this function. So a quick recap. We are importing certain things from GeoAlchemy to check the geometry type or the column type of your geometry column. Then we have also included the object of the name of the table spatial ref system to avoid it. And then we are simply referring to these functions in the context configure. And then over here we are importing async engine from config function, where we are passing all the information. I promise this is the only complicated file to deal with, and if you have set up this file correctly, believe me, you will not screw up. Now one last thing that I want to do is make change in this script.py.mako file. And what is this? If you don't do it right now, you will see that once your migrations are done, you will face an issue saying that GeoAlchemy not found. That is because whenever migrations happen, it actually creates Python functions. So for example, you can see SQLAlchemy is imported in this file, which means everything related to SQLAlchemy will work in migrations. And that's why we simply just import GeoAlchemy. That's all. There is nothing else that we have to change. Alright, now we are done with all the settings or all the changes that we need to do, and it's time for us to check whether this will work or not. And let's see. So I will start the generation of my migration by putting Alembic revision auto generate. Auto generate will save a lot of time because it will have a look at the models.py file and automatically figure out what all new things are there. And I will give the commit name as init, and I'll simply click on OK. And as you can see, I got my first error saying that can't locate revision identified by and then some random number. So these random numbers are generally generated whenever we create new migration file, and I think there is some kind of error with my configuration. So let me have a look at it. I will go to my INI and I will see that okay, I have missed the table name that we have just created. FastPG is actually referring to the table that I already have, and let me show you how these are connected. So if I go to FastPG and if I look for this Alembic version table, you will see that the same number is written over here. So what Alembic is trying to do is trying to find out a file with this number which will be the file parent to the current migration, and that's how Alembic is. Let me just show you that with a quick example. So first I will make change in this file, so I will make it as a fast video. Okay, now we will try to run our revision, and we are getting an error saying that type base has no attribute. So I think we have missed something. Yeah, so it should be base.metadata. Now we will try to run it again, and there you go. We have our first revision of auto generate done. Now if you go to versions, you will see that there is this init.py file. So for every migration we will have upgrade and downgrade, which means now if I first of all check my pgadmin, as you can see for our fast video we have only 2 tables, which means that the items table is not there. That is because we have only migrated it and we have created the migration file. It is not executed yet. Now to execute this, we will simply run Alembic upgrade head. Now when we will do this, this will actually run the upgrade command and then it will add this particular table. Now if I go to my pgadmin and refresh this, you will see that we have items table with us. And that's exactly how migrations will work with geometry as one of the columns. If you want to remove this table, you can simply do Alembic downgrade head and it will run all of these 3 commands. That means it will drop the index of the name, drop the index of ID, and then ultimately delete the table. Now as a part of your exercise, I want you guys to pause the video over here and try to create one more model and schema with some polygon or line string, and then try to create your own Alembic version of it. Now before we go ahead, I would like to make certain changes to the main.py file. This is something that we missed, and we will go ahead in our setting up the database and we will try to execute that over here. So what we want to do is copy this code and paste it in our main.py file. I have already done that. So what we are trying to tell over here is that whenever a FastAPI application is executed or initiated, we want to first of all run our engine, and we want to get the data from the engine, such as whether the connection is successful or not. Because think about in a direction, if you want to create APIs based on your database, you would want your database to be there. If the database for some reason is not working, your APIs will not make any sense, and that's exactly what we check over here using lifespan. You will see a lot of videos and content where it was something like on event of startup, like @app.onEvent startup, but this is something that is deprecated right now and we will not use that. We will go ahead with our async context manager. Great. So we have finished the hard part of setting up the migration. Now the only thing that is remaining is to create APIs. Now if you have created APIs with FastAPI in the past, you know the basic way to do that is having routers as a folder, where then each router will talk with a specific model, or it can be also divided based on the business logic. This is totally up to you. Now since we are going to deal with geometry as a data, we have to have one more package which is known as GeoAlchemy Shapely. So I will copy this, go to my terminal and paste it. There you go. And now I will create new file known as CRUD.py, in which I will put my CRUD operations. For the sake of this video, I am only going to create a post and a get call, that's all. I will do CRUD.py and paste it over here. Now let me walk you through all the things. First of all, we are creating a function known as createItem, where we are passing our session of database as one of the parameters and the item itself as another parameter. Here item is checked by the schema of item create that we created. That means your item body will have name, description and geometry. Now once we get this, we create our item and then we add that to the database and we commit to the database. And finally we are returning a status of 201 message added successfully. Similarly, we have created one more function of get items, where the only parameters is the database. And as I said that for the sake of this video, I am going to get all the data back in one go. If you want to do it based on ID, feel free to do that. Over here what we do is we are getting all the items and then we are creating a loop for all the items and converting the geometry into WKT element. If you don't do that, you probably will face an error saying that your geometry is some another UTF-8 or binary format, whereas it should be in a string format, because that's what we said when we defined the schema, that the result will always be string, which means it will be WKT. Now coming back to the CRUD file, we are then going to have a look at each one of this geometry, convert it into WKT element, and finally we will convert this element into the actual WKT string using the toShape function from GeoAlchemy Shape, which is the package that we recently installed. And there you go. So you have your CRUD operations ready. It's time for us to create routers for this. Now to do that, I will go to routers and then I will create a file items.py. Now over here I will write my routers. So I will copy the code from here and let's go through the code. We are initiating a API router and we are creating both APIs at /, that means at the parent URL. It's okay for us because one is post and one is get. So in post we will request user to send the item in a item create schema, and then we are sending our getDB function as a dependent to check the session. That means if the database is not working, you will not be able to execute this API. Then we are simply creating the item and then returning the response. And in another one, we are again simply reading the item based on the database and we are returning that response. Now the only thing that we need to change is main.py, where we will refer to this router and then we will initiate this router. Great. I think we are done with this. Now let's try to see this in action. I will go to my terminal and run uvcon main.app, reload, and there you go. Now if I go to /docs, I have my item for get and post as well as the default route. Now let's try to post some information. To do that, for now I will simply post a name, let's say rotten grapes, and description as GIS development company, and I will put some dummy point data of 73.21 space 19.18, and let's try to execute this. Now when we have executed, you can see that we got the message 201 added successfully. That means our data is in database. Let's have a look at it. I will execute the script and as you can see I have data over here, and if I look at geometry, it looks quite okay. Just like that I can keep on adding more things, like maybe 2, and I will say open source this time, and I will go with something like minus 105 or 103, 19, and there you go. And this is also added successfully. If I go to my database one more time, you can see I have 2 points over here. Now it's time for us to get this data, and to get we will simply hit this API, and as you can see we got description, geometry, ID and name, and geometry as a point. So again I would like you to pause this video and try to think that how you can get this data back in something like a GeoJSON format. So this is it for this video guys. I hope this was helpful to you. We created a FastAPI application, then we added the database credentials to it, then we created migrations, and finally we created APIs, and that's exactly how you create Spatial APIs using FastAPI. Thank you.